copy of the quiz, then we'll go over to do it. And then we're going to get into some new type of material. We're going to start studying geometry. And there are some kids that algebra drives them nuts. They have a really hard time with algebra. And then they do geometry and they're like, man, this stuff is really, really easy. So if you've been struggling a little bit during the course of the year, there's a pretty good chance that when we go through this geometry stuff, you're going to say, oh man, why isn't the whole year like this? This is so easy. And likewise, it's possible you've been doing really well all year, and you might struggle a little bit with the geometry, or you might just keep doing great. So we'll go through it step by step, and we'll see what we got. So here's some of the importance behind the quizzes. I don't know if you had a problem with the quizzes because it's the day after a vacation, Michael. I don't know why, but I expected lots of 75s and 100s. And that's not what we got. Got a handful of hundreds, I think maybe 3 or 4. If you got 100, raise your hand, please. 1, 2, 3, 300s. Okay. 75? 1, 2, 3, 4, 5 75s. I was really surprised. So that means that almost 3/4 of the class, 2/3 to 3/4 of the class, got a 50 or worse. And I was really surprised. I thought that we would do a whole lot better. All right, so the first one says, which does not represent the function. So the first question I want to ask you is, did you see the word not there? I did bold it and italicize it. So I thought you would have recognized it. Now, the thing that makes something not a function, there's a couple of ways to look at it. The first thing that makes something not a function is what we call the vertical line test. If I drew a picture like this, the first one, this would not be a function because as I draw it through, as you can tell, this touches twice. If it touches in any place on the graph, it doesn't have to be the whole graph, any place on the graph, if it touches 2 or more times, it's not a function. This one is a function because no matter where I draw a vertical line here, it touches only once on any vertical line. It never touches a second time. So the first thing you have to know about whether or not to tell if something's a function is the vertical line test. What's the vertical line test say, guys? Alan? Yeah, or more, right? Like if I made this look really funky, if I went like this and then this and then this and then this, that still wouldn't be a function. So it's 2 or more. Just sometimes I say 2 and I forget to emphasize that it's 2 or more. All right, there's another way to represent a function. I could go like this: 1, 2, 3, 4, 5, 6. This is as a set of ordered pairs, or I could go 1, 2, 1, 4, 5, 6. In this case, the second one is not a function. Can somebody explain to me why the second one is not a function? Alan? I'm sorry? Not because it skips a number. That's not important. There's another thing that makes it. Go ahead. Yeah, because there's 2 ones. See, the domain element 1 is repeated. If I was to graph this, here's the point 1, 2, and here's the point 1, 4. Wouldn't the vertical line touch twice? So another way to look at it is, if when I write a set of ordered pairs, any of the x's are seen more than once, then that's not a function. Choice C is 0, 1, 2, 3, and 5, 3, 1, 1, and it goes like this. That is a function. Because everything in the domain is what's on the left, everything in the domain only has one image. If I did this, now it's not a function. Because the 1 would have 2 different lines going from it. And that makes it not a function. And last but not least, choice D we did. Oh, choice A was a table. Well, look, a table is just like a set of ordered pairs. I got -2, 5, that's a positive 5. And then I have -1, 5, I have 0, 5, I have 1, 5, and I have 2, 5. Look at all the elements in the domain. The domain is the x's, -2, -1, 0, 1, 2. All of these guys, they're all only there once. If I ever saw it twice, like if I added another box and I wrote 2, 7, that would not be a function because the 2 appears twice. Okay? So make sure you understand how to recognize when something is a function and when it's not a function. Okay. Number 2. The thing that's important to realize, this is a simultaneous system of equations, and anytime we do simultaneous equations, we have to ask ourselves, is this a elimination technique or is it substitution? Who remembers what technique this is? Talk to me here, guys. Somebody raise your hand. Somebody who hasn't helped me yet. Alan, you've been great so far. I'm looking for somebody who hasn't helped. Stephen, is this elimination or substitution? It is, because you see them lined up on top of each other. And whenever they give you a part 1 elimination question, they're always going to make sure that one of the variables, Jalen, one of the variables is going to match. So if you look at this, I have positive 4 and negative 4y. So they go die, cancel each other out. I get 5x equals, because 3x plus 2x, just add them up, 5x. I add these guys up, I get nothing. Negative 2 and negative 8 makes negative 10. I divide by 5, and I get x is negative 2. And yes, you should be able to go back and plug in x, but if you just take a quick look at all the choices, do you see that there's only one choice there where the x is negative 2? Sam, you with me here? Right, taking a look. Do you see there's only one choice where x is negative 2? So that's choice D, so that's the correct one. Now, number 3 is a classic question that drives kids absolutely crazy. Kids struggle with this question every single year. I think every single 8th grade final exam, state assessment always has a question or two like this on it. It says 5 to the negative 4 times 5 to the 7. Now, before I answer that question, let's come out to the side here and let's do this. What is x to the 2 times x to the 3? X to the what, everybody? Everybody, x to the? Yes. X to the what?
Yes.
5th, good. I was waiting to hear 5. I didn't expect to hear 5th. Okay, good. X to the 5th power. Add exponents. 2 plus 3 is 5. So if I follow that rule here, I get 5 to the 3rd. So the first part of this question that's tricky is, do you know how to add negative 4 and positive 7? Look, there's 4 negatives. There's 7 positives. Whenever you have different signs, they're always going to wipe each other out. So you're going to subtract and keep the sign of the bigger number. You're going to actually end up with 3 pluses. Just shut your eyes, picture 4 negatives, 7 positives, you end up with 3 positives. Now, some kids want to say this, 25 to the 3rd. In one way, it kind of does make sense, but it's wrong because look, doesn't x stand for anything? Anything to a power times anything to the power, you always add the powers and you keep the anything. See, if I was to write this out, 5 to the negative 4 means 4 5s in the denominator. 5 to the 7 means 7 5s in the numerator. Die, 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 die. I'm left with 5 to the 3rd, not 25 to the 3rd. At no point in time do these 5s switch to 25s. So it has to say 5 to the 3rd power. Okay? And last but not least, f of x is equal to 4x minus 5. Now, it's very important that you say this when you look at this. The output is 4 times the input minus 5. Now, when I looked on your papers at your scrap work, everybody did the following. 4 times 1 minus 5. And then just about everybody had this. One person thought, I think it was you. It must be. Elizabeth felt 4 times 1 was 5. And 5 minus 5 was 0. But most people got to this step right here where they wrote 4 minus 5. That was really good. The problem is, this is 4 positives and 5 negatives. Which list is longer, guys? Hey, look at me. Which list is longer?
Negative.
The negative list. You know how many people put positive 1?
Me.
Yeah, a lot of people.
Not me.
A lot of people. Be careful about that tomorrow. We don't want to repeat that kind of mistake. Okay, so there's your quizzes. And tomorrow, you guys are going to go over this particular quiz and after we go over the quiz tomorrow, let me rephrase that. You have your quiz tomorrow. My advice between now and tomorrow, look over this quiz. If you have any difficulties, at the end of the period, I'm going to put this video up on the internet. Just take a few minutes to look over the quiz questions again. I think it'll really help you out for tomorrow. Now, you'll notice that, excuse me, you'll notice on today's Do It, a lot of the quiz questions are similar. That means we really want to reinforce these ideas. They're so important. Sam, I think you're a little bit out of space today. Let's get focused here, okay? Perry Langer is 8.05 times 10 to the 15th miles away from the sun. How many times further is it? Let me see what the other one is. That's 4.01 times 10 to the 10. So I'm going to divide 8.05 times 10 to the 15th divided by 4.01 times 10 to the 10th. Now, remember, it says about. When it says about, what does that tell you? It means it can be close. Doesn't have to be perfect. So I don't actually have to do this division. I could just say, what's 8 divided by 4? 2. And what's the rule with the exponents, guys? Subtract. So 2 times 10 to the 5th. Okay, next, number 2. Negative 4n plus 5 is less than 11. Let's solve it. What's the danger moment of this question before we even start? What do you have to be like? It's like a snake hissing at you, ready to bite. Go ahead.
Sign.
Yeah, the sign in front of the 4n, the negative 4n. I was watching, I don't know if you guys ever watched that show, The Incredible Dr. Pol. He's a veterinarian. My wife loves that show, and I watch it sometimes. And yesterday they had to do this thing to an alpaca.
Oh, yeah.
And you saw that one? He says,
Yeah.
Alpacas are very sensitive to pain. He says they get very, very difficult to deal with. He says they kick, they bite, they stomp, they hiss, they spit. They do everything to you when you try to correct them. On the other hand, I didn't notice horses don't feel their teeth. He went in there with these honking, big, long, like bolt cutters, grabbed the horse's tooth. He's like, "Argh!" He's pulling out the tooth, and the horse is like,
I was watching that. I was laughing.
right? I was like, whoa, man, you do that thing in my tooth, I'm gonna hit you. But the horse was like really mellow about it. So anyway, you gotta learn to recognize the danger. When Dr. Pol saw the alpaca, you could see him. He was like, oh man, I don't like these alpacas. So eventually,
I met him.
oh, did you really?
Yeah.
He's like a wacky guy.
Yeah, he is.
So eventually what they did was they brought the alpaca. He says, this is why we have a tree in our front yard. So they brought the alpaca over to the tree and they hooked him up to the tree. He goes, he's not going to pull a tree out of the ground. He's not that strong. So they did that and they got to work. So when I see this negative here, I'm saying, uh-oh, be careful. Be very, very careful. Minus 5, minus 5. Negative 4n is less than 6. Divide by negative 4. And here's the danger. Ready? I'm dividing by a negative. Now, I would not do this if it was a positive. What did I just say? I wouldn't do it if it was positive, but I do it if it's a negative. I got to switch the sign. Because I'm negating the less than. It becomes more than. And this is negative 1.5. So I'm looking for an answer on this list that's bigger than negative 1.5. There's only one choice, A, B, C, or D, that's bigger than negative 1.5. Which choice is bigger than negative 1.5? D, negative 1. Okay. Negative 1 is definitely bigger than negative 1.5. Think about it this way. Would you rather owe somebody $1 or $1.50?
$1.50.
Nothing.
You would rather owe me $1. I'm going to lend you $1. Give me back $1.50.
I like
Why
change.
not?
You go broke in a hurry that way.
I like change.
Okay,
I change.
next. Number 3, this is a negative 1/3. What's the output if the input is 6? Look, one of the things you have to be prepared for is how to handle a fraction times a whole number. It's an important skill. Just do the division. 3 goes into 6 how many times? 2. Negative 1 times 2 is negative 2. When we interpret this, this is 2 negatives and 5 more negatives. What does that come out to? 7 negatives. Good. Okay. Next up. I'm only going to do one of each of the next 2 because I want to make sure I get to the lesson. Okay? Actually, you know what? I'm not going to do 5 and 6 because it was like the quiz. Instead, I'll do both of these questions. We just went over 2 questions like 5 and 6. All right, so here we go. If I want to write the function rule, remember, it's always going to be y equals mx plus b, where slope is also known as rate of change. And the rate of change is the change in the y over the change in the x. How much is this guy going up by? 3. What's this guy going up by? 1. So the slope is going to be the change in the y over the change in the x. That's 3 over 1. How do I find the y-intercept in a table? That side of the room, we need a little more focus here. How do I find the y-intercept in a table? Alan? Much easier way than that. Much, much, much easier way. Kayla, how do you tell which number is the y-intercept? Yeah, whatever's paired up with 0. In this case, -4. So I'm going to get y equals the rate of change. The slope is 3. And then the y-intercept's -4. Super critical question to be able to answer. I'm pretty sure on the next series of quizzes, you're going to have to do that at least once, maybe twice. Also, on the next test, you know that question's coming. There's no way around. This is one of the most important things we do all year long. Now let's look over here. Again, we want to go y equals mx plus b, where m stands for rate of change. But this time it's t and d. So I'm going to go d equals mt plus b. Same idea, it's just instead of x and y, I go t and d. Now, what is the d's going up by? Go ahead. I'm sorry? It's going up by 24, it's good. And what are the t's going up by? 2. So this is going to be 24 over 2, not over 1. So it makes it 12. So I get d equals 12t plus, then the b matches up with 0. But the tricky part of this one is there's no 0 in the table. So I got to kind of work my way backwards. 8, 6, 4, 2, what would come next? 0. Then I'm going to go down 24. I'm at 40, because this is going up by 24. So if I'm going this way, I'm reversing. I got to go backwards. This is 16. God bless. So I get d equals 12t plus 16. Jimmy, you heading the game here? What's the matter? Did you stay up late every day during the vacation and now you can't get your wake-up time going here? Jimmy, man, you look like you didn't even wake up yet today. You got the whole sleepy hair head. You got the whole thing going on. All right. Now, one last thing. Guys, one last thing with this, do it. Notice, excuse me, notice, I want to fill in the value in this box. The easiest way to do it is once you come up with the rule, plug in the x. What's 3 times 10? 30. Minus 4? 26. Over here, plug in the 10. What's 12 times 10? 120. Plus 16 is 136. Okay? So that's the easy, once you make the rule, it's the quick and easy way to fill in the box. Okay. Now, here we go. You know, when I make up these quizzes, what I do so often is I look at do it from the previous week and the previous few days, and I start making them up. All right, so geometry, shapes. Look, first thing you should notice is there's no numbers, there's no letters, there's no nothing. At this point, we shift gears dramatically and we begin a most thorough study of geometry. The first thing that we have to do is understand relationships between shapes. Now, there's 2 types of relationships that shapes can have. You know how numbers can be equal? Like 2 equals, say, 4 over 2? Or 2 equals 2.0? Numbers are equal. Shapes are never equal. I would never say that triangle equals that triangle. I would use this word called congruent. And that's the first word that we have to learn today. If English is not your first language, that's got to be a weird word. There's no way that's a normal word, even if you speak English. How many people here have spoken English their whole life? How many times have you said the word congruent?
Probably 5 times.
Yeah, it's kind of weird. Listen, congruent means equal shapes. Everybody say that. Congruent means equal shapes. Okay, try to draw 2 congruent shapes on your paper real quick. I don't care what shapes they are. Just draw 2 shapes that are the same size.
Oh, no, it's very good.
Okay?
Oh, I got
All
one.
right. Now, one of these pairs, guys, pair 1 or pair 2, one of these 2 pairs is congruent.
2.
Which pair do you think is congruent? Everybody? 2. So pair 2 is, guys, pair 2 is congruent. And congruent means same size and shape. Same size and shape. Okay, this first pair this is what we call similar. Now, similar is a word that we've all used in English. Even if English is not your original language, you probably heard the word similar. Similar means it's kind of alike. There's something about it that's the same. So when I look for similar figures, what I'm looking for, actually, these aren't even similar figures because the lengths aren't proportional. I'll get to another pair. This is not similar, okay? This is nothing, but I want to define similar. Similar means same shape, which these do have, but it also means the sides are proportional, and it's not happening here. And we'll talk more about proportional in a minute, but I just want you to have that definition written down. That similar means same shape, sides proportional. And in this case, the sides are not proportional, so it's not going to be similar. Same shape, sides proportional. And we'll talk a little bit more about that. You did a lot of work with proportions last year. Okay, so now, and we're going to do the lesson today and tomorrow. It's going to be the same kind of lesson. Take a look at these guys. Are these the same shape?
Yeah.
Yes. But do you see how one's a little different size than the other?
Yeah.
That's a picture of similar. So number 3 is a picture of similar. Now, we can use similar to figure out the lengths of missing sides. Now, for this, I don't know if you know this or not, but in America today, it's very, very difficult to get by on the amount of money that any job produces. So in my spare time, I write songs. I do. Oh, I'm sure you've heard them on the radio.
No.
What kind of music do you listen to?
Right now?
All right, so you listen to rap crap. Okay, so here's the deal. Yeah, have you heard this one? A little Easter pig as a little Easter pig. A little Easter pig as a little Easter pig. Ha! You haven't heard that? Oh man, it was number 1 a couple of years ago. Big E and Little Weezy. They all borrowed it from me. They did. Anybody here listen to country? My good friend Garth Brooks borrowed it.
Mr. Linquist, I woke up this morning at 6 o'clock with country blasting in my living room.
There you go. Well, listen, you might have heard this. Little Easter bug as a little Easter bug. What? Listen, this is what we're saying here. You ready?
You sing so well.
What, are you laughing at my music? My feelings are hurt. Now look. Little. Hey. Guys. Hey, stay there. Hey. Stay there 1 minute. Ready? 8 is to 6 as 16 is to n. Cross multiply and get it done. Hasta la vista. Vaya con Dios. Day 2 tomorrow. Day 2 tomorrow. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. You heard that song, right? Yeah, I thought so. You probably have it like playing on your iPod all the time. Here we go.
Can I get my hat?
At the end of the day. Oh, you know better than wear hats in school.